Welcome to the infinite expanse of space, a place where time stretches beyond comprehension and distances are measured in light years. As we embark on this cosmic journey, let the vastness of the universe bring you peace, tranquility, and a sense of wonder. We have always been captivated by the mysteries of the universe, from ancient stargazers charting the stars in the night sky to modern-day scientists launching spacecraft into the unknown. Space has fueled our curiosity and imagination for millennia. Imagine yourself floating effortlessly, weightless, free from the bonds of gravity, drifting through the void of space. The stars above and below you twinkle softly, each one representing a distant world, a sun burning far beyond our reach. As we journey through these celestial bodies, feel the calm wash over you. We are but travelers, observing the beauty of the cosmos, a universe in constant motion. Close your eyes, if you wish, and imagine a sky without end, a sea of stars stretching infinitely in every direction. We will begin our journey at the heart of creation itself. The universe as we know it began 13.8 billion years ago in an event known as the Big Bang. From a singularity, a point smaller than an atom, the universe exploded into existence, expanding at an unimaginable speed. In the first moments of creation, space, time, matter, and energy all came into being. The universe, once a seething hot mass of particles and radiation, began to cool, and as it did, the first atoms formed. Hydrogen and helium, the simplest elements, dominated the young universe. Over millions of years, these atoms clumped together under the force of gravity, forming the first stars and galaxies. In the vastness of this early universe, galaxies were born, enormous collections of stars, dust, and gas, held together by the invisible force of gravity, spinning and swirling in the void. As we drift through space, imagine the birth of a galaxy. It begins as a cloud of gas and dust, slowly collapsing in on itself. For time, stars ignite, lighting up the darkness. These galaxies are the building blocks of the universe, each one home to billions of stars, each star potentially harboring planets. And some of those planets, perhaps, harboring life. The Milky Way is our home galaxy, a barred spiral galaxy, stretching over 100,000 light-years in diameter. It contains hundreds of billions of stars, each one the potential sun to planets that orbit around it. As we drift through the Milky Way, we pass through its spiral arms, regions dense with stars and interstellar clouds. These arms are where the action happens, where new stars are born in vast clouds of gas and dust called nebulas. Nebulas are the birthplaces of stars. These vast, colorful clouds of gas and dust are the cradles of the universe. Within these clouds, gravity pulls the gas together, creating dense regions where nuclear fusion ignites, giving birth to a new star. In the Orion Nebula, one of the brightest nebulas visible from Earth, hundreds of young stars are being born. Their light illuminates the surrounding gas, creating a glowing cloud that can be seen from thousands of light years away. As you float through the Orion Nebula, imagine the silence of space. There is no sound, no air to carry sound waves, only the soft glow of distant stars, the silent birth of suns that will shine for billions of years. Stars, like all living things, are born, they live, and they die. The life cycle of a star depends on its size. Small stars, like our sun, burn slowly and steadily, living for billions of years before they exhaust their nuclear fuel. When this happens, they expand into red giants, shedding their outer layers in beautiful, glowing shells of gas called planetary nebulas. These remnants of dead stars drift through space, their cores cooling and dimming, eventually becoming white dwarfs, the glowing embers of what was once a vibrant star. Larger stars, however, burn much more quickly. These stars live fast and die young. When they reach the end of their lives, they explode in spectacular supernovas, scattering their elements across space. The heavy elements formed in these explosions, iron, carbon, oxygen, are the building blocks of planets and of life itself. In the death of a star, new life is born. As we continue our journey, we pass through these remnants of dead stars, clouds of gas and dust that will one day form new stars and planets. The cycle of creation and destruction is endless in the universe, and we are fortunate to witness just a small part of it. Our solar system is located in one of the spiral arms of the Milky Way, called the Orion Arm. We are about 26,000 light-years from the center of the galaxy, in a relatively quiet neighborhood. Our Sun, a middle-aged star, has been burning for about 4.6 billion years and will continue to shine for another 5 billion years before it, too, becomes a red giant and fades into a white dwarf. As we drift further from the Sun, we pass the planets of our solar system. First, Mercury, the smallest and closest to the Sun, a rocky world with temperatures that swing wildly from searing hot to freezing cold. Next, Venus, a planet of intense heat and volcanic activity, its thick atmosphere trapping the Sun's heat in a runaway greenhouse effect. Then, Earth, our home, the only planet we know of that harbors life. As we move past Earth, we see Mars, the red planet, a cold desert world that may one day become humanity's second home. Further out, we encounter the gas giants, Jupiter and Saturn, their massive atmospheres swirling with storms and clouds. Beyond them, the ice giants, Uranus and Neptune, cold, distant worlds that are still largely a mystery to us. Finally, we reach the edge of the solar system, where the Kuiper Belt lies, a region of icy bodies and dwarf planets, including Pluto. Beyond the Kuiper Belt, the Sun's influence weakens, and we enter interstellar space, the space between stars. Here, in the cold darkness, we are truly alone, drifting between the stars, far from any planetary system. But even here, in the emptiness, there is beauty. The light from distant stars shines faintly, and occasionally, we encounter a rogue planet, a world without a star, wandering through the galaxy. As we drift further, we approach the center of the Milky Way. Here, in the galactic core, we find Sagittarius A*, a supermassive black hole with a mass 4 million times that of our Sun. Its gravity controls the orbits of millions of stars, pulling them into tight, fast orbits around the center of the galaxy. Black holes are among the most mysterious objects in the universe. Their gravity is so strong that not even light can escape once it crosses the event horizon. As we approach the black hole, time itself begins to slow, stretching out until it seems to stop completely. As we leave the galactic center and drift back into the spiral arms, we are reminded of the scale of the universe. The Milky Way is just one of billions of galaxies in the universe, each one containing billions of stars. And beyond our galaxy, in the vastness of the cosmos, lie even greater mysteries: dark matter, dark energy, and the fate of the universe itself. Dark matter is the unseen force that holds galaxies together. It makes up about 85% of the matter in the universe, yet we cannot see it or detect it directly. We know it exists because of its gravitational influence on visible matter, but its true nature remains one of the greatest mysteries of modern science. As we approach the end of our journey, take a moment to reflect on the beauty and wonder of the universe. From the birth of stars to the vastness of galaxies, the cosmos is filled with mysteries waiting to be uncovered. Though we are small in comparison to the vastness of space, our curiosity and desire to explore are limitless. As we venture beyond the Milky Way, the scale of the universe expands beyond imagination. Our galaxy is just one member of the local group, a collection of over 50 galaxies that are gravitationally bound together. The largest members of this group are the Milky Way, the Andromeda Galaxy, and the Triangulum Galaxy. Andromeda, our nearest spiral galaxy neighbor, is on a collision course with the Milky Way. In approximately 4 billion years, the two galaxies will collide, merging into a new, larger galaxy. Though this event is still far in the future, it is a reminder that even galaxies are not static. They too evolve, change, and sometimes combine. Imagine the slow, graceful dance of these cosmic giants as they approach one another. The stars within each galaxy are so far apart that they will not collide, but the immense gravitational forces will warp and reshape the structure of both galaxies. Over millions of years, the Milky Way and Andromeda will intertwine, their spiral arms stretching and distorting, until they finally merge into one. Beyond the local group lies the Virgo supercluster, a vast collection of thousands of galaxies, all connected by the invisible threads of gravity. The universe is structured like a cosmic web, with galaxies and clusters forming along filaments of dark matter. In between these filaments are enormous voids, regions of space where very few galaxies exist. These voids can span hundreds of millions of light years across, creating vast expanses of emptiness. As we continue our journey through the universe, we come across some of the most awe-inspiring and mysterious objects in existence. Quasars. Quasars are the brilliant cores of distant galaxies, powered by supermassive black holes that are actively feeding on surrounding gas and dust. As matter falls into the black hole, it heats up to extreme temperatures, emitting enormous amounts of light and energy. Quasars are some of the brightest objects in the universe, visible from billions of light years away. They serve as beacons, illuminating the distant reaches of the cosmos and providing clues about the early universe. The light we see from these quasars has traveled for billions of years to reach us, meaning that we are looking back in time, seeing these objects as they were when the universe was much younger. In fact, when we observe distant galaxies and quasars, we are witnessing the universe in its infancy, just a few billion years after the Big Bang. This ability to look back in time is one of the most fascinating aspects of astronomy. The farther we look, the deeper we peer into the universe's past. As we continue to drift through the universe, we encounter cosmic microwave background radiation, the faint afterglow of the Big Bang. This radiation is the oldest light in the universe, dating back to about 380,000 years after the Big Bang, when the universe had cooled enough for atoms to form and for light to travel freely through space. The cosmic microwave background provides a snapshot of the universe in its earliest stages, a time when it was still hot and dense, but beginning to take the shape that we see today. Beyond the cosmic microwave background lies the true edge of the observable universe. At a distance of about 46 billion light years, this is the farthest we can see with current technology. Beyond this horizon, the universe continues to expand, but the light from these distant regions has not yet had time to reach us. This is known as the cosmic horizon, the limit of our observable universe. Beyond it, there may be even more galaxies, stars, and wonders waiting to be discovered. As we approach the cosmic horizon, we enter the realm of speculation and theory. What lies beyond the observable universe? Some scientists believe that the universe may be infinite, stretching endlessly in all directions. Others propose that our universe is just one of many in a vast multiverse, each with its own laws of physics and unique properties. The idea of a multiverse suggests that there could be countless other universes, some similar to our own, and others completely different. These universes may exist in parallel with our own, or they may be separated by vast distances in a higher dimensional space. The concept of the multiverse challenges our understanding of reality, pushing the boundaries of what we can observe and comprehend. If other universes do exist, they may contain entirely different forms of matter, energy, and life. Some may have different physical constants, leading to worlds where gravity is stronger or weaker, or where time flows differently. The possibilities are endless, and as we contemplate these ideas, we are reminded of how little we truly know about the cosmos. As our journey through the universe draws to a close, let us reflect on the incredible vastness and beauty of the cosmos. From the birth of stars in glowing nebulas to the merging of galaxies, from the brilliant light of quasars to the faint glow of the cosmic microwave background, the universe is a place of wonder and mystery. We are small in comparison to the scale of the cosmos, but our curiosity and desire to explore will continue to drive us forward. Take a moment to breathe deeply and absorb the silence and serenity of space. Feel the stillness around you as the stars shine softly in the distance. As we drift back toward the Milky Way, let the calm of the universe wash over you, knowing that there is always more to discover, more to learn, and more to explore. The universe is vast, and our journey is far from over. In the years to come, new technologies and missions will take us further into space, revealing more of the universe's secrets. We will continue to search for exoplanets that may harbor life, to study the mysteries of dark matter, dark energy, and to unlock the origins of the universe itself. The adventure has only just begun. As we return to the familiar sight of the Milky Way, remember that every star, every planet, every galaxy is part of a larger cosmic story. A story that spans billions of years and stretches across unimaginable distances. We are a part of that story, a small but significant part of the universe's ongoing evolution. Take a final look at the stars, the glowing clouds of gas, and the distant galaxies. Let their light guide you as you drift into the peaceful embrace of the cosmos. The universe is waiting for you, and its wonders are endless. As we continue our journey beyond the galaxies and into the cosmic web, we encounter vast intergalactic voids, regions of space where galaxies are few and far between. These voids can span hundreds of millions of light years, creating immense areas of near-total emptiness. Yet, even in these dark voids, there are particles, tiny, subatomic particles zipping through space, remnants from the early universe. Though invisible to us, these particles tell the story of the universe's earliest moments, the first seconds after the Big Bang. Imagine drifting through this vast emptiness, where galaxies seem like distant islands in a sea of nothingness. This is intergalactic space, the realm between the great cosmic structures, where only the faint glow of distant galaxies illuminates the darkness. But even here, gravity has its influence. Galaxies are not evenly spread throughout the universe. They form along filaments of dark matter, connected in a web-like structure known as the cosmic web. This cosmic web is the largest structure in the universe, stretching across billions of light years, with galaxies clustering at the intersections of these filaments. As we move through this cosmic web, we encounter some of the universe's most ancient and distant galaxies. These galaxies formed when the universe was still young, just a few 100 million years after the Big Bang. Their light has taken billions of years to reach us, and by observing them, we are looking back in time to the universe's earliest epochs. These distant galaxies are often irregular in shape, much different from the well-ordered spiral galaxies like the Milky Way. In their chaotic forms, we see the universe's formative years when stars and galaxies were still assembling, shaped by gravity and dark matter. Now, let us turn our attention to one of the greatest mysteries of the cosmos, the fate of the universe. Will the universe continue to expand forever, or will it one day collapse in on itself? This question has puzzled scientists for centuries, and although we now know more than ever about the universe's structure, its ultimate fate remains uncertain. One possible scenario is the Big Freeze, where the universe continues to expand at an accelerating rate, driven by dark energy. As galaxies move farther apart, the stars within them will eventually burn out, leaving behind cold, dead remnants. For time, even these remnants, white dwarfs, neutron stars, and black holes, will fade into darkness. The universe will become a cold, empty place, with no energy or light, slowly cooling to absolute zero. In contrast, another theory suggests that the universe could end in a big crunch, where the expansion of the universe eventually slows and reverses. In this scenario, gravity would overcome the repulsive force of dark energy, pulling galaxies back together. Over billions of years, the universe would shrink, collapsing into a single, dense point, a reverse of the Big Bang. This final collapse could lead to the birth of a new universe, creating a cycle of expansion and contraction, known as the Big Bounce. There is also the possibility of the Big Rip, where dark energy continues to accelerate the expansion of the universe to the point where even atoms are torn apart. In this scenario, space itself is stretched so thin that galaxies, stars, planets, and even the smallest particles are ripped apart by the expansion of the universe. The fabric of space-time would unravel, and the universe as we know it would cease to exist. Each of these scenarios offers a glimpse into the far future of the cosmos, but for now, the universe is still young, only 13.8 billion years old. We are living in a time when stars are still forming, galaxies are still evolving, and life has emerged on at least one planet. The universe is in a state of dynamic change, and we are witnesses to its unfolding story. As we journey beyond the familiar stars and galaxies, let us pause to reflect on the very building blocks of the universe, the elementary particles. These tiny particles, smaller than atoms, are the fundamental components of all matter in the universe. The most familiar of these particles are protons, neutrons, and electrons, which make up the atoms that form stars, planets, and even our own bodies. The universe is also filled with more exotic particles, many of which were created in the first moments after the Big Bang. The study of elementary particles is known as particle physics, and it has revealed a world that is stranger and more complex than we ever imagined. At the heart of particle physics is the Standard Model, a theory that describes the behavior of particles and the forces that act on them. The Standard Model includes a variety of particles such as quarks, which make up protons and neutrons, and leptons, which include the electron. These particles interact through fundamental forces such as the electromagnetic force and the strong nuclear force. In addition to the particles described by the Standard Model, there are also force-carrying particles, known as bosons, which mediate the fundamental forces of nature. For example, the photon is the particle responsible for the electromagnetic force, while the gluon carries the strong force that binds quarks together inside protons and neutrons. One of the most famous bosons is the Higgs boson, often referred to as the God particle. The Higgs boson was predicted by the Standard Model, but it wasn't discovered until 2012, when it was detected by the Large Hadron Collider. This discovery confirmed the existence of the Higgs field, which gives particles their mass. As we contemplate these tiny particles, we are reminded that the universe is a place of both the infinitely large and the infinitesimally small. Just as galaxies and stars form the grand structure of the cosmos, particles like quarks and leptons form the building blocks of all matter. These particles have been around since the earliest moments of the universe, and their interactions have shaped the universe's evolution from the Big Bang to the present day. Speaking of the Big Bang, let us revisit this moment of creation, when the universe as we know it began. The Big Bang was not an explosion in space, but rather the rapid expansion of space itself. In the first fraction of a second, the universe expanded from a point smaller than an atom to a vast, hot, and dense state. This period of rapid expansion, known as inflation, stretched the fabric of space-time and smoothed out the distribution of matter, setting the stage for the formation of galaxies and stars. During the first few minutes after the Big Bang, the universe cooled enough for atomic nuclei to form in a process called nucleosynthesis. The most common elements created during this time were hydrogen, helium, and trace amounts of lithium. These light elements would later serve as the raw materials for the formation of stars, where heavier elements would be created through the process of nuclear fusion. As the universe continued to expand and cool, it entered a period known as the Dark Ages, the time before the first stars had formed. During this time, the universe was filled with a hot plasma of particles and radiation, but there were no sources of light. Eventually, about 380,000 years after the Big Bang, the universe cooled enough for neutral atoms to form, allowing light to travel freely for the first time. This moment is captured in the cosmic microwave background radiation, the faint afterglow of the Big Bang that we can still detect today. As the universe emerged from the Dark Ages, gravity began to pull matter together, forming the first stars and galaxies. These first stars were massive and short-lived, burning through their fuel quickly before exploding in supernovae. The heavy elements created in these supernovae seeded the surrounding gas, enabling the formation of second-generation stars and planets. Over billions of years, galaxies grew larger and more complex, and the universe became the rich and diverse place we see today. Now, let us turn our attention to one of the greatest unsolved mysteries in cosmology: dark matter. Dark matter makes up about 85% of the total matter in the universe, yet it does not emit, absorb, or reflect light, making it invisible to telescopes. We know dark matter exists because of its gravitational effects on visible matter. For example, the rotation speeds of galaxies suggest that they contain far more mass than we can observe. Without dark matter, galaxies would not have enough mass to hold together, and they would fly apart as they spin. Dark matter is thought to form a halo around galaxies, extending far beyond the visible stars. These halos help to bind galaxies together and prevent them from being torn apart by their own rotation. But despite its importance, we still do not know what dark matter is made of. Scientists have proposed several candidates for dark matter particles, including WIMPs, weakly interacting massive particles, and actions, but so far, no direct evidence has been found. The search for dark matter is one of the most active areas of research in modern astrophysics. Experiments are underway to detect dark matter particles directly, and new telescopes are being developed to study the effects of dark matter on the large-scale structure of the universe. As we continue to explore the cosmos, we hope to unravel the mystery of dark matter and discover its true nature. Just as dark matter shapes the structure of the universe, dark energy is driving its expansion. Dark energy is a mysterious force that makes up about 70% of the total energy content of the universe, and it is responsible for the accelerated expansion of space. This discovery, made in the late 1990s, was a shocking revelation to scientists who had previously believed that the expansion of the universe was slowing down due to gravity. Instead, they found that the universe is expanding faster and faster, driven by the repulsive force of dark energy. The nature of dark energy is one of the biggest puzzles in cosmology. Some scientists believe that dark energy is a property of space itself, while others propose that it could be a new type of energy field. Whatever it is, dark energy will play a crucial role in determining the fate of the universe. If dark energy continues to accelerate the expansion of space, the universe may eventually experience a big freeze, where galaxies, stars, and planets drift apart, and the universe becomes cold and dark. As we ponder the mysteries of dark matter and dark energy, we are reminded that the universe is still full of unknowns. For all the progress we have made in understanding the cosmos, there are still vast regions of space and time that remain beyond our reach. The more we learn, the more we realize how little we truly know. Let us now return to one of the most spectacular and awe-inspiring events in the universe: supernovae. Supernovae are the explosive deaths of massive stars, and they are among the most energetic events in the cosmos. When a massive star runs out of fuel, its core collapses under gravity, causing the outer layers of the star to be ejected into space. This explosion releases more energy in a few seconds than the sun will emit over its entire lifetime, and the light from a supernova can outshine an entire galaxy. There are two main types of supernovae, Type I and Type II. Type I supernovae occur in binary star systems, where a white dwarf star pulls material from its companion star. When the white dwarf reaches a critical mass, it explodes in a thermonuclear blast, Type A supernovae occur when a single massive star exhausts its nuclear fuel and undergoes gravitational collapse. The core of the star collapses into a neutron star, or black hole, while the outer layers are blown into space. Supernovae are not only spectacular, but they are also crucial to the evolution of galaxies. The heavy elements created in supernovae are scattered into the surrounding gas, enriching the interstellar medium with the raw materials needed to form new stars and planets. In fact, most of the elements that make up Earth, including the carbon in our bodies and the oxygen we breathe, were created in the hearts of stars and dispersed by supernova explosions. In this sense, we are all made of stardust. As we leave the fiery remnants of supernovae behind, let us take a moment to consider the importance of star formation in the evolution of the universe. Stars are the engines of the cosmos, transforming simple elements like hydrogen into heavier elements through the process of nuclear fusion. Without stars, there would be no planets, no life, and no light. Stars form in molecular clouds, vast regions of gas and dust that are cold enough for atoms to clump together. When a region of a molecular cloud becomes dense enough, gravity causes it to collapse, forming a protostar. As the protostar continues to collapse, its core heats up and nuclear fusion begins, igniting the star and allowing it to shine. As we drift through time and space, let's turn our attention back to Earth, our small blue planet that orbits a middle-aged star on the outskirts of the Milky Way. From this distant vantage point, Earth is just a pale blue dot, a tiny speck of light in the vast darkness of space. And yet, this small world is home to all known life in the universe. It is here that humanity has looked up at the stars for thousands of years, wondering what lies beyond the sky. For much of human history, the stars were seen as distant points of light, the domain of the gods. Ancient cultures built monuments to track the movements of the sun, moon, and stars, using them to mark the passage of time and the changing of the seasons. The Great Pyramids of Giza, the Stonehenge, and the ancient cities of Mesopotamia were all aligned with the heavens, reflecting the deep connection that early civilizations had with the cosmos. As our understanding of the universe grew, so too did our desire to explore it. The invention of the telescope in the 17th century revealed that the stars were not just points of light, but distant suns, each one a world of its own. This was the beginning of modern astronomy, a field that would revolutionize our understanding of the universe. In the centuries that followed, astronomers discovered new planets, mapped the surface of the moon, and identified distant galaxies. But it wasn't until the 20th century that humanity took its first steps beyond Earth. The space age began in 1957 with the launch of Sputnik 1, the first artificial satellite to orbit the Earth. Just a few years later, in 1961, Yuri Gagarin became the first human to journey into space, orbiting the Earth in his spacecraft, Vostok 1. The pinnacle of human space exploration came in 1969, when Apollo 11 carried the first astronauts to the surface of the moon. Neil Armstrong and Buzz Aldrin became the first humans to set foot on another world, leaving behind footprints that will last for millions of years. The success of the Apollo program was a testament to human ingenuity and determination, proving that we could venture beyond our planet and explore the solar system. Since then, humanity has continued to push the boundaries of space exploration. Robotic missions have landed on Mars, explored the outer planets, and even ventured beyond the solar system. The Voyager 1 spacecraft, launched in 1977, is now the farthest human-made object from Earth, traveling through interstellar space. More than 14 billion miles away, it carries with it the Golden Record, a message to any extraterrestrial civilization that might one day find it, containing sounds and images from Earth. A snapshot of humanity at a single moment in time. Today, we stand on the cusp of a new era of space exploration. Private companies like SpaceX and Blue Origin are developing technologies that could make space travel more accessible than ever before. In the coming decades, we may see the first human missions to Mars, the establishment of lunar bases, and the development of space tourism. The dream of living and working in space is no longer science fiction. It is becoming a reality. As we look to the future, we are reminded of the vastness of the universe and the endless possibilities it holds. The stars are our destination, and the journey has only just begun. As our journey through space comes to an end, take a moment to reflect on the incredible vastness and beauty of the universe. From the swirling arms of the Milky Way to the distant quasars at the edge of the observable universe, the cosmos is filled with wonders beyond imagination. Though we are small in comparison to the scale of the universe, our curiosity and desire to explore are boundless. The universe is vast, and it is waiting for us to discover its secrets. Every star, every planet, every galaxy is a part of a larger story, a story that we are just beginning to understand. As we drift through the cosmos, we are reminded that we are a part of this story, connected to the stars, the planets, and the galaxies in ways that we are only beginning to comprehend. Take a deep breath and let the silence of space wash over you. The stars will continue to shine, the galaxies will continue to evolve, and the universe will continue its journey through time and space. And we, as part of this universe, will continue our journey as well. As we continue to journey through the vast expanse of space, let us turn our attention to some of the most remarkable objects in the universe: neutron stars and pulsars. Neutron stars are the incredibly dense remnants of massive stars that have exploded in supernovae. When a star runs out of fuel, its core collapses under gravity, crushing atoms together so tightly that protons and electrons merge to form neutrons. The result is a neutron star, an object so dense that a sugar cube-sized amount of its material would weigh billions of tons. Neutron stars are among the most extreme objects in the universe. They are small, only about 20 kilometers in diameter, but they pack more mass than the sun into this tiny space. The surface gravity of a neutron star is so intense that if you stood on its surface, you would be crushed instantly. These stars rotate incredibly fast, sometimes spinning hundreds of times per second. When a neutron star spins this rapidly, it becomes a pulsar, emitting beams of radiation from its magnetic poles. As the pulsar rotates, these beams sweep across the sky like the beam of a lighthouse. And if one of these beams points toward Earth, we can detect it as a regular pulse of radio waves. Pulsars are cosmic clocks, their rotations so precise that they can rival atomic clocks in their accuracy. Some pulsars rotate so quickly that they are called millisecond pulsars, spinning hundreds of times per second. The fastest known pulsar spins more than 700 times per second, and the forces at play in such a system are nearly beyond comprehension. The study of pulsars has revealed much about the universe, from the nature of neutron stars to the existence of gravitational waves. As we drift away from these rapidly spinning objects, we encounter another extreme phenomenon: magnetars. Magnetars are a type of neutron star with a magnetic field, a trillion times stronger than Earth's. These magnetic fields are so powerful that they can distort atoms, and they occasionally release bursts of X-rays and gamma rays. The energy released in one of these bursts can equal the amount of energy the sun emits over the course of 100,000 years. Magnetars are rare, and their intense magnetic fields remain one of the great mysteries of modern astrophysics. Now, as we move deeper into the galaxy, let's take a moment to appreciate the role of galactic collisions in shaping the universe. Although the distances between galaxies are vast, galaxies themselves are constantly in motion, and over billions of years, they often collide and merge with one another. These cosmic collisions are slow, graceful events, taking hundreds of millions of years to unfold. When two galaxies collide, their stars rarely crash into each other directly due to the vast distances between them. But their gravitational fields interact, causing the galaxies to warp and distort. During these collisions, gas clouds within the galaxies are compressed, triggering a burst of star formation. This is known as a starburst, and it can create thousands of new stars in a relatively short period of time. Over time, the two galaxies will merge into a single, larger galaxy, often with a new shape. For example, two spiral galaxies may merge to form an elliptical galaxy. These galactic mergers are a natural part of the universe's evolution, and they play a key role in the formation of large galaxies like the Milky Way. In fact, the Milky Way itself has experienced multiple mergers over its history. Billions of years ago, our galaxy merged with several smaller galaxies, adding their stars to our galactic disk. Even today, the Milky Way is in the process of merging with several dwarf galaxies, including the Sagittarius dwarf galaxy and the Canis major dwarf galaxy. Over time, these galaxies will be absorbed into the Milky Way, their stars joining the billions already in orbit around the galactic center. One of the most dramatic events in the future of the Milky Way will be its collision with the Andromeda Galaxy, which is currently heading toward us at a speed of about 110 kilometers per second. In about 4 billion years, the two galaxies will collide, and over the next few billion years, they will merge to form a new galaxy. This new galaxy, sometimes called Milky Way, will be an elliptical galaxy with a completely different structure from the spiral shape we know today. Although this may seem like a violent event, the vast distances between stars mean that very few stars will actually collide. Instead, the night sky will be transformed as Andromeda's stars become visible alongside those of the Milky Way. As we continue our exploration of cosmic phenomena, let us turn our attention to gravitational waves. Gravitational waves are ripples in the fabric of space-time, caused by some of the most energetic events in the universe. These waves were first predicted by Albert Einstein in his theory of general relativity, but they were only directly detected in 2015 by the LIGO experiment. Gravitational waves are produced by events such as the merger of black holes or neutron stars, and they travel through space at the speed of light. When two black holes orbit each other, their intense gravity distorts the space around them, creating waves that propagate outward. As the black holes spiral closer together, the frequency of these waves increases, creating a chirp that can be detected by gravitational wave observatories on Earth. The discovery of gravitational waves has opened a new window into the universe, allowing us to observe events that are invisible to traditional telescopes. It has also confirmed that black holes exist and that they can merge to form even larger black holes. The study of gravitational waves is still in its infancy, but it holds great promise for the future. As new, more sensitive detectors are built, we will be able to detect even more events, including the merging of neutron stars, the collision of black holes, and possibly even the ripples created by the Big Bang itself. Gravitational waves offer a new way to explore the universe, revealing phenomena that were previously beyond our reach. Now, as we return to the more familiar regions of space, let's explore the fascinating worlds of exoplanets, planets that orbit stars beyond our solar system. Since the first exoplanet was discovered in 1992, astronomers have identified thousands of these distant worlds, and the discoveries continue to pour in. Exoplanets come in a wide variety of sizes and types, from gas giants like Jupiter to super-Earths, rocky planets larger than Earth. Some exoplanets orbit close to their stars, while others are located in the habitable zone, where conditions might be right for liquid water and potentially life. One of the most exciting developments in exoplanet research is the discovery of Earth-like planets. These planets are similar in size to Earth and are located in their star's habitable zone, where temperatures could allow for the presence of liquid water. One such planet is Proxima Centauri b, which orbits the star Proxima Centauri, the closest star to the Sun. Proxima Centauri b is located just over 4 light-years away, making it one of the closest exoplanets to Earth. Although we do not yet know if it has an atmosphere or if it harbors life, it is a tantalizing target for future exploration. Another fascinating class of exoplanets is the hot Jupiters, gas giants that orbit very close to their stars. These planets are so close to their stars that their atmospheres are heated to thousands of degrees, causing them to glow with infrared radiation. Some hot Jupiters are so close to their stars that they are tidally locked, meaning that one side of the planet always faces the star, while the other side is in perpetual darkness. This creates extreme temperature differences between the two sides, with the day side reaching scorching temperatures and the night side remaining freezing cold. As we study these distant worlds, we are reminded of the incredible diversity of planetary systems in the universe. Each star is a potential host to planets, and each planet is a world of possibilities. Some exoplanets may have moons, oceans, and atmospheres, while others may be barren, rocky landscapes. The search for exoplanets is still in its early stages, but as our technology improves, we will be able to study these worlds in greater detail, searching for signs of life and clues to the origins of planetary systems. As our journey through space comes to an end, let us reflect on the incredible variety of phenomena we have encountered, from the birth of stars in nebulae to the collisions of galaxies, from the extreme gravity of black holes to the gentle ripples of gravitational waves. The universe is filled with wonders beyond imagination. Each star, each planet, each galaxy tells a story that is still unfolding. We are fortunate to live in a time when we can explore these distant worlds and cosmic events, using telescopes and instruments that reveal the universe in all its complexity. Yet, for all that we have discovered, there is still so much we do not know. The universe is vast, and its mysteries are many. But with each new discovery, we come closer to understanding the fundamental forces that shape the cosmos and our place within it. Take a deep breath and let the silence of space fill you with a sense of peace and wonder. The stars will continue to shine, the galaxies will continue to evolve, and the universe will continue its journey through time. And we, as part of this universe, will continue to explore, to learn, and to dream. As we continue to explore the process of star formation, let us take a closer look at the environments where stars are born. The giant molecular clouds. These clouds are immense, often spanning hundreds of light years, and they contain the raw material from which stars are formed. Hidden within the cold, dark depths of these clouds, gravity pulls gas and dust together to form protostars. Over the course of millions of years, these protostars will grow, ignite, and become fully fledged stars. One of the most famous star-forming regions in the Milky Way is the Orion Nebula, a stellar nursery that is visible to the naked eye on a clear night. The Orion Nebula contains hundreds of young stars, some of which are still surrounded by protoplanetary disks, swirling disks of gas and dust that may eventually coalesce to form planets. These star-forming regions are incredibly dynamic, with gas and dust being shaped by the intense radiation from nearby stars. Over time, the nebula itself will dissipate as its gas is used up in the process of star formation. Within these molecular clouds, new stars can form in groups, creating what is known as a star cluster. Star clusters can be either open clusters, which contain a few hundred to a few thousand stars, or globular clusters, which are much larger, containing tens of thousands to hundreds of thousands of stars. Open clusters are typically younger and are often found in the spiral arms of galaxies, while globular clusters are much older and are found in the halos of galaxies, orbiting far above and below the galactic disk. As we drift through one of these stellar nurseries, imagine the birth of a star deep within the cloud. The gas begins to collapse under its own gravity, forming a dense core. As the core collapses, it heats up, and when the temperature reaches millions of degrees, nuclear fusion ignites, and a star is born. This process is happening all over the universe, in galaxies near and far, and it has been happening for billions of years. Every star you see in the night sky was once a protostar, hidden deep within a molecular cloud. Now, let's turn our attention to one of the most fascinating and complex processes in the universe: the formation of planetary systems. Round young stars, disks of gas and dust form, and within these disks, particles begin to stick together, forming clumps that grow larger over time. Eventually, these clumps become planetesimals, the building blocks of planets. As these planetesimals collide and merge, they grow into protoplanets, and over millions of years, these protoplanets clear out their orbits and become full-fledged planets. The formation of planets is a chaotic and violent process. Early in a star system's history, the young planets are bombarded by comets and asteroids, and many protoplanets are destroyed in collisions. But over time, the planets settle into stable orbits, and the chaos subsides. This process played out in our own solar system billions of years ago, as the planets formed from the disk of gas and dust that surrounded the young sun. One of the most intriguing aspects of planetary formation is the possibility of habitable planets, worlds where conditions are just right for liquid water to exist. These habitable planets must be located in the habitable zone of their star, where temperatures are neither too hot nor too cold. Earth, for example, is located in the Sun's habitable zone, and it is the only known planet where life has emerged. But with the discovery of thousands of exoplanets, scientists are hopeful that habitable planets exist elsewhere in the galaxy. In addition to planets, many star systems also contain moons, which orbit around their parent planets. Some of these moons are as large as planets themselves, and some may even harbor life. One of the most promising candidates for life in our solar system is Europa, a moon of Jupiter that is covered in a thick layer of ice. Beneath this ice, scientists believe that there is a vast ocean of liquid water, heated by tidal forces from Jupiter's gravity. If life exists anywhere else in our solar system, Europa is one of the best places to look. In addition to planets, many star systems also contain moons, which orbit around their parent planets. Some of these moons are as large as planets themselves, and some may even harbor life. One of the most promising candidates for life in our solar system is Europa, a moon of Jupiter that is covered in a thick layer of ice. Beneath this ice, scientists believe that there is a vast ocean of liquid water, heated by tidal forces from Jupiter's gravity. If life exists anywhere else in our solar system, Europa is one of the best places to look. As we leave the familiar realms of star and planet formation, let's travel further into the mysteries of galaxy formation. Galaxies are the fundamental building blocks of the universe, and they come in a wide variety of shapes and sizes, from spiral galaxies like the Milky Way to elliptical galaxies and irregular galaxies. The formation of galaxies is a process that began in the early universe, just a few 100 million years after the Big Bang. In the beginning, the universe was nearly uniform, with only tiny variations in density, but over time, these variations grew as regions of slightly higher density attracted more matter through gravity. These regions became the seeds of galaxies, and as the universe expanded, galaxies began to form from collapsing clouds of gas and dark matter. The formation of galaxies is closely tied to the behavior of dark matter, an invisible substance that makes up about 85% of the matter in the universe. Dark matter does not interact with light, which is why we cannot see it directly, but its gravity shapes the structure of the universe. In fact, galaxies form within dark matter halos, with the visible stars and gas occupying only a small fraction of the total mass of the galaxy. Without dark matter, galaxies would not have enough mass to hold together, and they would fly apart as they rotate. As galaxies form and evolve, they undergo a series of mergers and interactions with other galaxies. These galactic mergers play a key role in the growth of galaxies, as smaller galaxies are absorbed by larger ones. Over billions of years, galaxies grow larger and more complex, with massive black holes forming at their centers. These supermassive black holes can have masses millions or even billions of times that of the Sun, and they are responsible for some of the most energetic phenomena in the universe, such as quasars. Quasars are the brilliant cores of distant galaxies, powered by supermassive black holes that are actively consuming material. As gas and dust fall into the black hole, they heat up to extreme temperatures, emitting enormous amounts of light and energy. Quasars are so bright that they can outshine their entire host galaxy, and they can be seen from billions of light years away. In fact, quasars are some of the most distant objects we can observe, and they provide a glimpse into the early universe when galaxies were still forming. As we travel through the universe, we encounter some of the largest structures in existence: galaxy clusters. Galaxy clusters are massive conglomerations of hundreds or even thousands of galaxies, bound together by gravity. These clusters can span millions of light years across, and they are often surrounded by even larger structures known as superclusters. The Milky Way, for example, is part of the local group, which contains about 50 galaxies, and the local group itself is part of the Virgo supercluster, one of the largest structures in the universe. As we drift through one of these galaxy clusters, imagine the incredible forces at play. The galaxies within the cluster are moving at incredible speeds, interacting with one another through gravity. Some galaxies may be on a collision course, while others are being pulled apart by the gravitational tides of the cluster. The space between galaxies is filled with hot gas, heated to millions of degrees by the motion of the galaxies. This gas emits X-rays, making galaxy clusters some of the brightest objects in the universe when viewed in the X-ray spectrum. At the heart of many galaxy clusters lies a cooling flow, where the hot gas cools and condenses, creating new stars and fueling the growth of the central galaxies. These central galaxies are often the largest and most massive in the universe, with masses hundreds of times that of the Milky Way. The central black holes of these galaxies can grow to enormous sizes, feeding on the gas and dust in the cluster and emitting powerful jets of energy that can influence the entire cluster. As we move beyond the galaxy clusters, we begin to encounter the cosmic web, the large-scale structure of the universe. The cosmic web is a vast network of galaxies, clusters, and superclusters, connected by filaments of dark matter and separated by enormous voids. This structure spans the entire universe, with galaxies forming along the dense filaments of dark matter. The cosmic web is a reflection of the universe's early density fluctuations, amplified by gravity over billions of years. As we drift through the cosmic web, we are reminded of the incredible scale of the universe. The structures we see today, the galaxies, clusters, and superclusters, are the result of billions of years of evolution, shaped by gravity, dark matter, and the expansion of space. The universe is a place of constant change, and as we look deeper into space, we are also looking back in time, witnessing the universe as it was billions of years ago. As we approach the edge of the observable universe, we enter the realm of the cosmic horizon. This is the farthest distance from which light has had time to reach us since the observable universe began. Beyond this horizon, we cannot see, as light from these distant regions has not had enough time to travel to us in the 13.8 billion years since the Big Bang. However, the universe continues to expand beyond this limit, and what lies beyond the cosmic horizon is one of the greatest mysteries in modern cosmology. The cosmic horizon represents the boundary of what we can observe, but it is not a physical boundary. Beyond this horizon, the universe continues, potentially for infinity. Some theories suggest that the universe could be infinite in size, stretching endlessly beyond what we can see. Others propose that the universe may be finite, but unbounded, curving back on itself like the surface of a sphere, meaning that if you travel far enough in one direction, you would eventually return to your starting point. As we approach the cosmic horizon, we are reminded that our place in the universe is both central and insignificant. From our vantage point on Earth, we can observe galaxies billions of light years away, and yet we are confined to a small corner of the universe, limited by the speed of light and the expansion of space. The vastness of the cosmos is humbling, but it also inspires a sense of wonder and curiosity. What lies beyond the horizon? What is the ultimate fate of the universe? These are questions that have intrigued humanity for centuries and continue to drive our exploration of the cosmos. As we turn our gaze back toward the Milky Way, let us contemplate the future of the universe. The expansion of the universe, driven by dark energy, will continue to accelerate, pushing galaxies farther apart. Over billions of years, the night sky will change as distant galaxies move beyond the cosmic horizon, disappearing from view. Eventually, only the galaxies in our local group will remain visible, while the rest of the universe fades into darkness. This scenario, known as the Big Freeze, is one possible fate of the universe. In this scenario, stars will continue to form for trillions of years, but eventually, the supply of gas needed for star formation will run out. As stars die and are not replaced, the universe will grow darker and colder. Over time, even the remnants of stars, white dwarfs, neutron stars, and black holes will fade away, leaving behind a cold, empty universe. In this far future, the last remaining energy will come from the decay of black holes. According to Hawking radiation, black holes slowly lose mass by emitting radiation, a process that takes trillions of years for even the smallest black holes. Eventually, all black holes will evaporate, leaving behind only a sea of radiation and subatomic particles. This marks the end of the universe as we know it. A cold, dark, and empty expanse where no new stars can form and no life can survive. Yet, this is only one possible outcome. Some scientists propose that the universe may undergo a big rip, where the accelerating expansion caused by dark energy becomes so extreme that even atoms and subatomic particles are torn apart. In this scenario, the very fabric of space-time would be ripped to shreds, and the universe would be destroyed in a catastrophic end. Alternatively, the universe could experience a big crunch, where the expansion of space eventually slows and reverses. In this scenario, gravity would overcome the repulsive force of dark energy, and the universe would begin to collapse in on itself. Galaxies, stars, and planets would be drawn together as space contracts, and the universe would end in a hot, dense state similar to its beginning in the Big Bang. Some theorists suggest that this collapse could trigger a new Big Bang, creating a cyclical universe that expands and contracts in an endless loop. As we consider these possibilities, we are reminded of the complexity and beauty of the universe. Its fate remains uncertain, and the more we learn, the more questions we uncover. The universe, in all its vastness and mystery, continues to inspire awe and wonder. It is a place of constant change, where stars are born, live, and die, where galaxies collide and merge, and where the forces of nature shape the cosmos on the grandest of scales. As we return to the present, let us take a moment to reflect on what we have seen. We have traveled through space and time, witnessing the birth of stars in glowing nebulas, the violent deaths of massive stars in supernovae, the swirling dance of galaxies, and the mysteries of dark matter and dark energy. We have explored the smallest particles that make up all matter and the largest structures that span the cosmos. Throughout our journey, we have seen that the universe is a place of extremes, extreme sizes, extreme temperatures, extreme densities, and yet, it is also a place of balance and harmony, where the forces of nature work together to create the galaxies, stars, planets, and life that populate the cosmos. As we gaze up at the night sky, we are reminded that we are a part of this vast universe. The atoms in our bodies were forged in the hearts of stars, and the light we see from distant galaxies has traveled billions of years to reach us. We are connected to the universe in ways that are both profound and humbling. Our journey through the universe may be ending, but the exploration of the cosmos continues. New telescopes and missions are being developed to peer deeper into space, to study distant exoplanets, to understand the nature of dark matter and dark energy, and to unlock the secrets of the universe's origins. The more we learn, the more we realize how much there is still to discover. As we return to Earth, take a deep breath and let the silence of space wash over you. The universe is vast, and its wonders are endless. We are only at the beginning of our journey, and the possibilities for discovery are infinite. The stars will continue to shine, the galaxies will continue to evolve, and the universe will continue to expand. And we, as part of this cosmic journey, will continue to explore, to learn, and to dream. If you enjoyed this video, don't forget to give it a thumbs up and subscribe to the channel for more space journeys like this.